This is a second example to illustrate the difference that you have between the disk washer method versus the shell method. So I want to find the volume of the region bounded by y equal to x squared and y equal to the square root of x revolved about the line y equal to 4. So I have y equal to x squared down there drawn in red, and I have y equal to the square root of x drawn in blue. So first of all, I need to find the points of intersection. So a little bit of algebra. I get that x squared is equal to the square root of x, and if I square both sides, that gives me that x to the fourth is equal to x, and then if I subtract, set this equal to 0, I get x to the fourth minus x is all equal to 0. Do a little factoring. We get x times x to the third minus 1 is all equal to 0, and that is going to give us that x is equal to 0 or that x is equal to 1. So I have my 2 points of intersection up here on my graph. I have here at the origin 0, 0, and this point over here, which is the point 1, 1. So now, two different ways we could approach this problem. We could either approach it with the disk washer method, or we could approach it with the shell method. So first method that I'm going to use the disk or the washer method. Now again, I'm calling it the disk/washer method just for the sake of doing that, because the book that I'm using for my class is doing it that way. So, but again, they're both the same method. It's just with one method the inner radius is 0, and with the other method the inner radius is not 0. But this approach you take is the same in either case. So with the disk or washer method, I need every one of my rectangles that I draw here that's going to represent my outer radius and my inner radius. I need those to be perpendicular to my axis of revolution. So my axis of revolution is horizontal, y equal to 4. So my rectangles that I draw here are going to be vertical. So everything's going to be with respect to x. So if I draw a rectangle that represents my outer radius, then I'll notice that every one of those rectangles is going to start and stop in the same location, so I don't have to split this region into a couple of different pieces. And very rarely do you have to do that with either one of the methods, but just be careful about that. So if I label my endpoints of this rectangle, which I strongly encourage you to do, it'll help you tremendously. It takes all the guesswork out of it. Then I have the point x, 4. And if I label the point down here at the bottom of this rectangle, that's some x value, and my y value on that curve there in red is x squared. So that tells me that my outer radius, capital R of x, the farther distance, is 4 minus x squared. And then if I draw another rectangle here that represents my inner radius, which goes to my line in blue there, then my top point there is still x, 4, and at the point on this curve here, it's just some x value, and my y value is the square root of x. So my inner radius, little r of x, is 4 minus the square root of x. So now I have everything that I need to set up for the disk or washer method. So it's going to be the volume is equal to pi times the integral. And if I look at my picture back up there, I'm integrating with respect to x. So my x values in my picture up there go from 0 to 1. So it's going to be pi times the integral from 0 to 1 of my outer radius, which was 4 minus x squared. That's squared. Minus my inner radius, which is 4 minus the square root of x. That value squared, all that dx. Now because I'm going to do this from the other standpoint in just a few minutes with the shell method, I'm going to go ahead and work this out. You could plug this into your calculator and get a decimal approximation, but we can integrate this. It just takes a few minutes to work this out. So this is going to be pi times the integral from 0 to 1. If I take 4 minus x squared and I square it, I'm going to get 16 minus 8x squared plus x to the fourth. Excuse me. Minus, take 4 minus the square root of x and square that. That's going to be 16 minus 8 times the square root of x plus x, all that dx. And if I forget to write the dx, I apologize. Just we understand with respect to x here. So my volume is going to be pi times the integral from 0 to 1. I have a positive 16. And when I distribute my negative into all three of these terms there, I'm going to end up with a negative 16, so those are going to cancel. And so what I'm going to be left with is I'm going to be left with x to the fourth minus 8x squared If I distribute that negative, that's going to become a positive 8 times the square root of x, and then a minus x, all that dx. Just cleaning that up a little bit. Alright, so that's 4 terms. So if I just integrate each one of those terms, my volume is going to be pi times, no more integral. I'm going to integrate this. This is going to be 1/5 x to the 5th minus, if I integrate x squared, it's going to be x cubed, so this is going to be over 3. So it's going to be 8/3 x to the 3rd. Plus, if I integrate x to the 1/2, that's going to be 2/3 x to the 3/2. So I'll have an 8 there. So this is going to be a 16/3 x to the 3/2. And then minus a 1/2 x squared. And all that's going to be evaluated from 0 to 1. Alright, so my volume is going to be pi times, if I plug in 0, they're all going to disappear, so that's good. If I plug in 1, those are all going to be 1, so I'm just going to be left with 1/5 minus 8/3 plus 16/3 and then minus 1/2. So get a common denominator of 30, and my volume is going to be pi times all this over 30. So that's going to be 6/30. Multiply that by 10, that's going to be in minus 80. Multiply 16 by 10, that's going to be 160. And multiply 1 by 15, that's going to be minus 15. If you add all those up there, you have negative 80 and 160, which gives you a positive 80, plus 6, 86 minus 15, is going to give me 71 pi over 30 for my final answer there. Alright, just so that my video doesn't run too long, I'm going to stop this one. And the second half of this video will be the same problem, but I'm going to do it with the shell method as opposed to the disk method that I just did.